Okay, I guess this is part 2 of the video, and of course okay, here we go. So we remember that depending on what group or family an element is in, that tells us how many dots in the dot diagram there are. So in group 1, those elements all have 1 dot. In group 2, they have 2 dots. In group 13, they have 3. In group 18 for helium, helium gets 2, but the rest of them have 8. So we can see this bigger picture of the periodic table. You guys are familiar with that, and you could fill in these blanks about group 1 has 1 outer ring electron, and group 2 has 2 outer ring electrons. And then we think about group 13 having 3. Group 14 has 4 outer ring electrons, so 4 dots. Group 15 would have 5 dots. Group 16 would have 6 dots. 17 would have 7 dots. And group 18 would have 2 for helium or 8 for the rest of them. And that would be a full shell. Now, some of you may be thinking, what about these middle rows, families? Well, it's a little more complicated, and we'll let high school science discuss that with you. There are different ways of thinking about how their electron shells are filled. Okay, so moving on. If I gave you an assignment to fill in all these dots, you could do that. You could find them on the periodic table, see which family they're in, and fill in the dots. And that was kind of my original intent with that. Remember that a chemical bond is the force of attraction that holds the atoms together as a result of the rearrangement of the electrons. So it's all about this rearrangement of the electrons, and sometimes how they're shared or even given up or loaned. Okay, so applying the periodic table shows where all those elements are at, and then you can figure out how many valence electron. So we are going to find out that group 1 are very reactive. They have 1 dot, 1 valence electron. They are really super ready to make a chemical bond or a chemical reaction. Elements in group 17 have 7 dots, and they have 1 empty space, so they too are eager to make compounds. So I want you to know that group 1 and group 17 make good compounds, because to total those up together, if you added them all up, that would be 8. And then they would be a full outer ring, much like group 18. Group 2 and group 16 are kind of the same way as well. 2 outer ring electrons plus 6 outer ring electrons would be 8. All right, here's some more of that dot diagram stuff that you've already done. Now, I want you to know that the noble gases are stable elements and they don't want to make compounds. I want you to know that the metals typically lose valence electrons because they have fewer than 4 outer ring electrons. So metals are typically thought of as lenders. Our packets this week will be talking more about that. So our group 1 want to lend their 1 outer ring electron pretty easily. And again, the metals in group 2 want to lend their 2 pretty easily. Non-metals like to pick up or gain electrons because their outer rings are almost full. So they want to go ahead and fill up their outer shells. Okay. Metalloids, depending on where they're located and how many they have, if they have more than 4 outer ring electrons, they want to pick some up. Typically, I think they want to gain electrons. Okay. I think that's it. Good luck with those questions. Email me if you have questions.